Hello my dear students. Welcome back to NEET World. So today in this session we will be discussing aldehydes, ketones, carboxylic acid, and this is our part 2 on aldehydes, ketones, carboxylic acids, right? So in the last session we have discussed their preparation methods and also some chemical properties we have discussed, right? Physical and chemical properties. Okay, so let us re-look into the chemical properties of aldehydes, ketones, carboxylic acids, especially its chemical reactions, like it will undergo, carbonyl compounds will undergo nucleophilic addition reactions. We are going to discuss about this nucleophilic addition reactions. Okay, right, write the heading as nucleophilic addition reactions of carbonyl compounds. So first of all, write the structure of a carbonyl group. So how can you write this carbonyl group means, C double bond O. So on this carbon, if at least one hydrogen is present, then you can say aldehydic functional group. If both sides only alkyl groups are present, then what you can say? Like only alkyl groups are present, you can say ketone. Okay. So now what I discussed, the hybridization of the central carbon here is sp2. Therefore it can be a trigonal planar compound. Okay. Now what happens when we are doing nucleophilic addition? What do we mean by nucleophilic addition? A nucleophile will come and attack over this electrophilic carbonyl carbon. Okay, why it is electrophilic? Because oxygen drags the pi bonded electrons towards itself from the carbon. Okay, so now what happens? It is creating partial positive charge, that is electron deficiency created over the carbon side right now. So there our nucleophile can come and attack like this. Okay, so now I will be giving you some stereochemical approach also. Just listen me what I am saying here. See, I am writing C double bond O, two groups like this. See, it's a trigonal planar molecule, right? Like this, if you consider it's a trigonal planar, like this, you can consider it like this. A nucleophile can come and attack it from the above the plane side like this, or equally possibility for below the plane right now. So now we can get a nucleophile from above the plane or from below the plane, so that the final product, see what is the final product actually when nucleophile is attacking here? See, two groups as it is, and this O becomes O minus and a nucleophile is coming here right now. Okay, now followed by hydrolysis, it means acidic hydrolysis, or you just adding some proton here. So now what happens? So it becomes OH and a nucleophile as it is like this. Okay, so now what makes the difference here? See, we got an sp3 tetrahedral product here, because this central carbon, now what is the hybridization? 4 sigma bonds means sp3, so it's an sp3 hybridized compound. Now it is coming from an sp2 product substrate now. So now this nucleophile can attack from above or from below, equal possibilities I told you. So now tell me, what are the products formed here? So nucleophile can be above the plane. It means I can write a nucleophile like this. Okay, OH, a nucleophile above the plane like this. Okay, same OH, a nucleophile from below the plane like this. So both possibilities are there now. So if this is a clockwise direction rotating molecule, optically rotating compound, it is, see, chiral center now. So it will be now become anti-clockwise rotating molecule. So if the product formed is 50% mixture, then we can call this as a racemic mixture product. What I can say? Racemic mixture product, plus or minus or with equal amount means we can say it's a racemic mixture. So if racemic mixture is formed, see, this is rotating plane polarized right, and equally this is rotating left. Therefore net rotation becomes 0. That's why it is optically inactive. Racemic mixture is optically inactive. This is the concept to be remembered here. Okay, right. Now what I am explaining in the previous slide, a nucleophile can attack on this carbonyl group carbon right now. So now I will be giving you one simple way to understand this, the reactivity order. See, RH I have, and another carbonyl group I am taking. Both of them are small hydrogens only like this. Now we are taking a nucleophile like this. See, if these group sizes are small, if these attached group sizes are small, nucleophile entry will be very easy. But if this group size is very bulky, like very large, now what happens? The entry of nucleophile will be difficult. Therefore, what I can say, as alkyl groups are bulkier, the nucleophilic addition reaction will be less, because if these are bulky, nucleophilic addition will be difficult. Okay. So now tell me, there will be 3 options given in this manner. Okay. Now R means consider alkyl groups. See, do we have any alkyl groups here? No, small hydrogens only we have, and in this case one alkyl group, one hydrogen. So small group is present here. Here both of them are alkyl group, both of them are bulky groups only. Here one bulky group. Now tell me, in which of this case nucleophile can attack easily? Yeah, it can attack easily in the first case, because small size now, so no hindrance to attack. So it will easily attacks in this case. So the rate of nucleophilic addition reaction will be like what I can say, the rate of nucleophilic addition reaction will be more in this smaller case. So now what is the order of rate of reaction here? 1, 2, 3. So this is how you need to give your answer. Okay, is this clear? Is the concept is clear or not? Yes. If the concept is clear, please tell me your answer for the next question here. Which one of the following is most reactive towards nucleophilic addition? Which is most reactive towards nucleophilic addition? Yes, tell me, how can you answer this? Yeah, here you have only hydrogen. Okay, and what about this case? You have CO and one CH3 group is there. And in these 3 cases, see, this is aldehyde only now, right? So C double bond O H is there, like this. Aldehyde means. Here also it is C double bond O H is there, like this. Okay. Now a nucleophile can attack a carbonyl group. A nucleophile can attack a carbonyl group when these groups are smaller in size. Nucleophile can easily attack on a carbonyl group carbon easily when the groups attached are smaller, and also if this carbonyl carbon is more electron deficient. See, if this fellow is more electron deficient, what it will look for? It will look for electrons from other species. So if it is more electron deficient, nucleophilic attack is easy, because it is looking for nucleus now. So it will provide a space to attack by this nucleophile. Now tell me, what type of group attached here? NO2. See, this is also aldehyde, this is also aldehyde, this is also aldehyde. But what type of group here we have? And what type of group here it is? Methyl. So it is electron releasing group. And what type of group here we have? Nitro means it is an electron withdrawing group. Now what it will do? It will withdraw electrons towards itself from the ring, and that will create more positive charge on this carbonyl group. So therefore nucleophile can easily attack over here. Is this clear? So C will be most reactive towards nucleophilic addition reaction. Okay, is this clear? Yeah. If the concept is clear, please click on the like button. Okay, let's move forward with one more question here. Right. So tell me, in the 4 options, which is more reactive towards nucleophilic addition? Yeah, easy again. Write the structures properly. See, they have given it like this now. So how do you write this? CH3, C double bond O H, and this is as it is given. Now what about this? CH3, C double bond O CH3, acetone, CH3, CH2, COH, aldehyde. So which is more reactive? Tell me. The smaller groups I told you. Where do we have smaller groups? In first option. See, just hydrogen, methyl. In other case it is bigger alkyl groups. So which is more reactive? First option. Now from our discussion, see, these are aldehydes, these 2 are ketones. This is again aldehydes. See, aldehydes are more reactive than ketones, because aldehydes are more electron deficient than ketones. Okay. So electron deficient compounds readily undergo nucleophilic addition reactions. Okay, they will readily undergo nucleophilic addition reactions. Okay, and the next point here I can mention, So aldehydes are more reactive than ketones. Aldehydes are more reactive than ketones towards nucleophilic addition reactions or in nucleophilic addition reactions. Is this clear up to here? Right. Let's move forward. Yeah. Yeah, in the chart box someone is answering 1. Yes, perfectly correct. Right, let us move forward. Yeah, tell me, acetone is treated with excess of ethanol in presence of hydrochloric acid. The product obtained here is, see, I will explain now first, then you can answer me this question. Yeah, see, whenever we are adding, let us say there is one acetone here, this is an acetone. To this I am adding ethanol. What we are adding? Ethanol. Ethanol means you can write it like this. Now what happens, tell me? The oxygen lone pairs can attack on this carbonyl group here. Okay, and the reaction is taking place in which medium? Acidic medium. Okay, let us say it is happening in acidic medium. Okay, so now what happens is, whenever it is happening in acidic medium, this proton is taken by the lone pairs here. Okay, now tell me what happens? CH3, C, OH, CH3. Like this it will form first because proton get attacked by this oxygen lone pairs. Next what happens? Like this we have. See, now oxygen is having positive charge now. It will drag this pi bond towards itself. So the lone pair electrons of ethyl alcohol will be attacking. Okay, gives you CH3, COH, CH3, here OET will be there. Okay, so now this proton will be removed out, so that we will get like this. Okay, now see this form, you just understand what I have made. See, a carbon having 2 alkyl groups like this, 2 alkyl groups and 1 OH group and 1 OR group, it means alkoxide group is there. So if this kind of product is forming from a ketone, you should call it as hemiketal. What I am saying? Hemiketal. Okay, and if one more ethyl alcohol is also added, what I am saying, one more ethyl alcohol in acidic medium is added. Now what happens, tell me? So both of this, like one more OH is there now, this OH also get deprotonated by addition of H plus and this OET will attack, so that it will gives you CH3, C, CH3, OET, again OET, like this. Okay, it means what we got here finally, C, R, OR dash and OR dash. It means 2 alkoxy groups are there, 2 alkyl groups are there. So now whenever on the same carbon from ketone, what we got? From a ketone we got on the same carbon 2 alkoxy groups are there now. So you should call it as a ketal. What you should call? Ketal. So this is hemiketal, ketal. So what is the difference between ketal and hemiketal? See, hemiketal has OH, ketal has both OR groups only, like alkoxy groups only. Okay. Similarly, if it is forming from acetaldehyde, like aldehyde, what I am saying, it is forming from aldehyde. See, I am taking an aldehyde here, C double bond O, CH3, H. So tell me what happens if I add one alcohol in acidic medium? What it will form? You tell me, I will write here CH3, C, OH and this hydrogen as it is, and this becomes OR, like this. Okay, this is called, see, aldehyde now. So you will get hemiacetal. What will get? Hemiacetal. If I add one more mole of alcohol, what happens, tell me? This OH, H plus removed as water and this alcohol will be added. So that will get CH3 CHOR OR. So what is the name of this compound? It is acetal. What you can call? Acetal. So this is hemiacetal and acetal. Okay. So why we are particularly discussing their names? Because hemiacetal and hemiketols, you will be seeing this kind of structures in biomolecules, the chemical reactions of biomolecules. We will be studying about this. Okay. And this hemiacetal hemiketol forms can be reduced by Tollens and Fehling's reagent. What I am saying? Hemiacetal and hemiketol forms can be oxidized by, they can be oxidized by Tollens and Fehling's reagents. Okay. So this can be undergo oxidation using hemiacetal and hemiketols. So if these forms are there in the carbohydrates, those are nothing but sugars only, no? Carbohydrates are considered to be sugars. So in sugars, if these forms are there, carbohydrates, if these forms are there, they can be acting as a reducing sugars. What can I say? Reducing sugars. It means they can be get oxidizes by Tollens and Fehling's. See, reducing sugar means it will reduces others, oxidizes itself. Okay, a reducing sugar upon treating with Tollens and Fehling's reagent undergoes oxidation. So what happens to our reducing sugar? Will undergo oxidation. Okay, whereas that Tollens and Fehling's reagents get reduced. Okay, so now these forms are there means we can say they can act as a reducing sugars in carbohydrates. Okay, remember, if it is in this form, ketol and acetal form is there, so they can act as reducing sugar or not? No, they cannot act as reducing sugars. Okay, so this is what you will study in biomolecules. Okay, and one more thing, one best example. Now just tell me sucrose. Glucose plus fructose. Okay, now what is the glycosidic linkage they have? So now just look, since you are a NEET students, now what I am saying, you just write the glycosidic linkage, 1,4 or 1,2, you just write the glycosidic linkage. Okay, so now just look which type of formation they have, whether hemiacetal or hemiketol, ketol or acetal, which form it has. If they have ketol form or acetal form, they can be non-reducing sugars. If they are in this form, they can be reducing sugars. Okay, so your answer should be mentioned in the comment box for this particular question. Okay, yeah, you got this now? Yeah, the next. Yeah, tell me here, acetone is treated with excess of ethanol in presence of hydrochloric acid. The product obtained here is, what is the product obtained? Yeah, acetone. What is the structure of acetone? Just now we discussed. CO, CH3, CH3. Acetone is treated with excess of ethanol in acidic medium. Yeah, tell me what I told you. Excess. If only one equivalent taken, so it becomes hemiacetal or hemiketol form. Since it's a ketone, it becomes hemiketol form. But excess taken now, what happens? It becomes ketol form. What is the ketol form of it? See, CH3, CH3. So just remove double bond and add this OET groups. O ethyl, ethyl. Okay, yeah. This kind of structure. Where do we have? See, OET ethyl groups. Yeah. So this is your answer for the question. Okay, is this clear? The next, reduction reactions of aldehydes and ketones. So aldehydes, ketones can undergo reduction. Okay, so what are the ways it can undergo reduction of aldehydes and ketones? First one is reduction to hydrocarbon. See, a carbonyl group, an aldehyde or a ketone, an aldehyde or a ketone can be converted into respective hydrocarbon. Okay, so it means wherever we have C double bond O now, that will be converted into CH2 unit. Methylene group is formed from C double bond O. Okay, so this conversion happens by either by Clemmensen reduction or by Wolff-Kishner reduction. These are the two ways we can do. So Clemmensen reduction means it happens in acidic condition. Okay, Wolff-Kishner reduction happens in basic condition. So now I will tell you one by one, just see what I am saying. C double bond O or H. It can be aldehyde or a ketone. Okay. So now if I am treating this with ZnHg, what is this? Zinc amalgam we can call. What we can call? Amalgam in acidic medium. In which medium? Acidic medium. So wherever you are seeing C double bond O now, just write them. See this part as it is I have written, but in the place of double bond O, I am writing 2 hydrogens like this. So that is nothing but, do we have any carbonyl group here? No. So what it is happening here? Like an alkane, see that is R CH3 group is formed. It's an alkane or not? Yes. So we got our alkane as a product. What is the product formed? Alkane. Okay, is this clear? So we got respect to hydrocarbon. Okay. Now tell me, if I treat this with NH2, hydrazine. What is this? Hydrazine in basic medium. In which medium? Basic medium under heating condition. For this heating condition is required. So now what happens is, this C double bond O group is there now, same, convert into same, like whatever we discussed above, same product will be formed here also. Okay, but what makes the difference? Yes, this reaction takes place in acidic medium, this reaction takes place in basic medium. It means during the chemical reactions, chemical synthesis, looking at the substrate, we need to decide which type of reaction is suitable for this conversion. Okay, if the substrate contain any acid sensitive groups, we should not use that. See, for example, acid like, see, sensitive group means what I can say. See, I have a compound like this. Yeah. So if I add any acid here, what happens if I use HCl? What happens is OH and this H plus will react. So that is acidic sensitive group now. So I should not use a Clemmensen reduction here. So I can go with this Wolff-Kishner reduction, so that it will not get disturbed. It will remain as such. Only this will be converted into, this remains as it is. This will be converted into respect to alkane, like CH3 unit is formed. So what is a suitable reagent I can use for this transformation? Above 1 or below 1? Below 1. Wolff-Kishner reduction, that is NH2, hydrazine in basic medium under heating condition. Okay, is this clear? Right. So this is how you need to remember the concepts. Okay, right. Next. Okay, what is the name of these two reactions? One is Clemmensen, other one is Wolff-Kishner. Okay, right. So reduction of carbonyl compounds, aldehydes, ketones to respect to alcohols to be discussed. Yes, we will discuss that. But tell me before that, see what we need to discuss now, a reduction of carbonyl group to respect to alcohols now. See, for example, here one alkyl group is there, some R dash, so I am writing that R dash as it is, but what I want to get, I need to convert this C double bond O to COH. Okay, so what makes the difference from here to there, tell me? OH, and the next, here there is only alkyl groups, but here along with alkyl groups we have hydrogen. So addition of hydrogen, what is that process called? Reduction. So can I say carbonyl compounds will undergo reduction process? Yes, they are undergoing reduction process. So for this process we are using something called reducing agents. What is that? So reducing agents provides hydrogen. What they will produce is hydrogens. Now what can be these reducing agents? It can be lithium aluminium hydride or sodium borohydride. Okay, lithium aluminium hydride or sodium borohydride, or even it can be B2H6. Okay, so like this we can have different reducing agents. Okay, so now here if you observe, there is a question. The question contains both ester functional group and as well as one ketone functional group. But if you observe, ester functional group is remained undisturbed, but only ketone is converted into alcohol. So for this process, which reagent is suitable, they are asking. How can you answer? Yeah, see, if the given reducing agent has more reactivity, means it will react everywhere. I mean, wherever there is reactive site, they will go and react. Okay, but if the given reducing agent have very less reactivity, so now what it will do? It will selectively reduces some compounds which are more electron deficient. Okay, see, because all of these compounds will be giving you hydrides. What is the name of this compound? Lithium aluminum hydride. Hydride, it means H minus is provided. This is also sodium borohydride. Okay, like hydride I am saying now. So it means what they will provide? Hydride ion they will provide. Okay, that will be attacking at these carbonyl groups. But you know, lithium aluminum hydride is more reactive than sodium borohydride. So it will reduces both ester as well as ketone functional group. So but I do not want both transformation, I want only this one. So I can use for this transformation NABH4. Why? Because it will be a weak reducing agent compared with lithium aluminum hydride. So selectively reduces more electron deficient carbonyl group. Why I am saying this is more electron deficient group here, ketone is more electron deficient? Because on this ester functional group, if you observe, the lone pair electrons of this oxygen are in conjugation with this ketone oxygen compound. So now due to this reason, it becomes it has like electrons from the adjacent, but there is no such kind of help from others to this carbonyl group carbon. Okay, that's why it is more electron deficient compared with the ester. So what is the suitable reagent? Sodium borohydride. Okay, sodium borohydride. Remember this. Okay, sir, why not diball H, you might be asking. See, diball H, diisobutyl aluminum hydride it is. So it can also reduces esters to respect to aldehyde, but I do not want any conversion here. That's why I am not using it. Okay, right. And this will provide hydride ion that can attack at both sides, so not suitable. Okay, right. Now again, what are the physical properties it can have? Yeah, let's discuss its physical state, order, boiling point, solubility. Yeah, already we have some idea on this. Anyways, let's see with some practical data. See, physical state, this graphical representation shows boiling points. See, boiling points for different compounds. See, it's a C4H10 means simple hydrocarbon. Okay, here it is an ether, here it is an aldehyde, here again an ether, it is a ketone compound. Again here we have an alcohol. See, always remember, alcohols are have more boiling point than the other compounds. Okay, in the last class also I discussed. Why? Because due to the hydrogen bonding in the alcohols. Okay, right. So that's why it has highest boiling point compared to the other compounds of same or similar molecular weight, nearest molecular weights. Okay, right. So the next ketones, the next aldehydes. Okay, and ethers list and hydrocarbons list. So which is most first? Alcohol. Okay, and the next ketones, the next aldehydes, and after that ethers, and least is for hydrocarbons. Okay, from this data you can understand this point right now. Right. Yeah, let's move forward. Yeah, so arrange the given following compounds in the increasing order of their boiling points. How can you arrange this? Yes, based on our discussion. See guys, for every explanation I am trying to provide some questions. Okay, so first explanation, then next question, so that you will get more confidence. Okay, so this is how we can revise or pick, understanding will be there. Yes, tell me for this, which is increasing order, like write the increasing order of these compounds. Hydrocarbon is there. So hydrocarbons lowest boiling points, because non-polar, there is no interactions, effective interactions are not present. So propane will be least, and after that, yeah, alcohol is there. So alcohol more boiling point due to hydrogen bonding. So ethyl alcohol will be highest. Okay, and between these two, what I told you, aldehyde and ketone. What I told you, ketones are more now. See, ketones are more than aldehydes. So here it becomes ketone, acetone it becomes here. Okay, and this one becomes like acetaldehyde, CH3COH. Okay, so this is the order of the given question. Okay, hope those who are following in the live session is you got some clarity over this discussion, right? Yeah, let's move forward with few more things. Yeah, chemical properties we discussed. these things oxidation, yeah, we'll do about this now, we'll do discussion on this oxidation now. And the next reaction due to alpha hydrogen, and there are some miscellaneous reaction. And guys, you know, from carbonyl compounds you can expect one named reaction in the final exam. There are many different named reactions like aldol, Cannizzaro, okay, and Beckmann rearrangement, already we discussed in alcohols chapter. Okay, anyways, I will explain Baeyer-Williger oxidation, all these are there, we will discuss them. Yeah, see, this is based on our discussion. Tell me, overall increasing order of reactivity of the given compounds is, which is more reactive, tell me from our discussion? Nucleophilic addition reactions, or more reactive, which is more reactive? Clearly I have explained. More reactive means if it is more electron deficient, that will be more reactive. And the next point I told you, smaller the alkyl groups or smaller the groups attached to the carbonyl group, that is more reactive. Based on these 2 points you can answer me now. Yeah, so look at here, only hydrogens are there. So which is more reactive? E, okay, and after E, just see one hydrogen here. So aldehydes are more reactive now. So D, like this, you just tell me what will be your answer for this question based on our discussion in the comment box. I want answer for this in the comment box for this particular, like I want arrangement, which is more reactive, which is least, like that, okay, right. Yeah, so the next nucleophilic addition reactions we have studied, okay, like a carbonyl group will be there, to that we are adding a nucleophile. So this nucleophile will attack on this carbonyl group carbon and gives you a tetrahedral product like this, O minus NO, like this I told you, okay. So now we have different types of nucleophile. The different types of nucleophile upon reaction with carbonyl group will get different types of products, okay. We will see one by one here. See, first thing is C double bond O R H, let us say this is the carbonyl group we have, and I am taking our nucleophile as ammonia. What is our nucleophile? Ammonia. Now what happens is ammonia lone pairs can attack on this carbonyl group carbon, okay. Now what happens? R C O minus H NHC, this is lone pairs attacking here now, so it becomes NH3 place, so I am writing NH2, that proton is transferring here like this, okay. After that again lone pair electrons are there on the nitrogen atom, okay, and oxygen also having, so there will be some repulsions between these lone pairs also, okay. Now what happens? Oxygen tries to go out from here as a OH minus, okay, so but not as OH minus ion, but by taking proton from here, so what happens? So it will be forming R C N H, okay, and here it is going out as a water molecule. So what is the product formed here? So C in the place of oxygen we got nitrogen now. So C double bond N, we should call it as imines. What we can call? Imines. Sir, we want a simplest way to understand this, we do not want all these many steps. So I will tell you, simple, listen to me. What I am writing? Same carbonyl group I have written over here, okay. So now here I am writing NH2 like this I am writing. See, just remove this as a water molecule. If you remove water molecule, what is the remaining part? R H double bond N H. So that is called imine. What we can call? Imine. Okay, we can call it as imine. Yeah. So if it is NH3 ammonia, you can say it as imine formation. If it is amines, what it is forming? Amines. If amines are the reagent, amines are the nucleophile, the product formed should be called as a Schiff's base. What is that? Schiff's base. Okay. So imine formation when it is ammonia, and Schiff's base formation when it is alkyl amine, R group is present. Okay. When it is hydroxyl amine is there, like see, if it is NH2 group, amine we are saying now. So one hydroxy, OH means hydroxy. So hydroxyl amine. So if it is hydroxyl amine, the product formed is called as oxime. What is the product formed? Oxime. Now what is the reaction taking place? Yeah. So as I told you here, just to remove water molecule from nitrogen to hydrogen and oxygen. Yeah, here also from hydroxylamine you just remove 2 hydrogens from nitrogen and oxygen from carbonyl group. Okay, that's how you can make the product formed here is, hydroxylamine means you will get an oxime. Okay, if it is hydrazine is a nucleophile, the product formed is hydrazone. Okay, if the nucleophile here is a phenylhydrazine, you would call it as a phenylhydrazone. Okay, if here it is 2,4-DNP. What do we mean by 2,4-DNP? See, write the structure along with me. 2,4-dinitro phenylhydrazine. See, NH2. This is called phenylhydrazine, and 2,4-dinitro. See, at second and third, fourth position we have 2 nitro groups, and phenyl ring here we have 1 hydrazine. So you can call in the short form as 2,4-DNP. So 2,4-DNP, okay, upon treating this 2,4-DNP with our carbonyl group, what happens? These 2 hydrogens and this oxygen will be removed as water, so that you will get a compound like this, NH, NO2 and NO2. This is what the product formed here. Okay, so 2,4-DNP derivative is formed. Okay, this is also like a hydrazone derivative only. Okay, product formed. Okay, so now using this we can identify whether the compound given aldehyde ketones or not by considering when it is combined with other things. Okay, right. The next one, if it is a semi-carbazide, we will get a semi-carbazone. What we are going to get? Semi-carbazone. So what do we mean by semi-carbazide first of all? So you just write it as C double bond O, NH2 one side, and another side is NH2. What is the name of this compound? Semi-carbazide or carbazine. This is the starting material. Okay, now they will ask you A, B, C. Which part of this semi-carbazide will react with the carbonyl group? Which nitrogen? Either A, B, C. Which nitrogen will react with the carbonyl group carbon, they will ask. Okay, now how can you identify this? Tell me. See, the one which is at the terminal, this side, not this side, because these two are in conjugation, little bit in conjugation with the carbonyl group. So these are isolated. So it is free to attack on this carbonyl group. So that's why this terminal will be attacking on the carbonyl group carbon. Okay, that it will be more nucleophilic. Okay, right. So that is how you can identify the nucleophilic nature order also. Okay, right. And not only that, we can also say it as an alpha effect. Alpha effect means whenever there is a lone pairs side to side, the nucleophilicity of one lone pair will be dominated, will become more due to the presence of the adjacent group. Okay, right. So these are the products form. I hope the discussion is clear. Right. Those who are in a live session watching this, if the discussion is clear, please click on the like button. Okay, right. So again, to the carbonyl group, if you are adding HCN, okay, what is the nucleophile here? HCN in presence of NaCN. The product formed is called cyanohydrin. What is the product formed? So cyanohydrin means one side OH, another side is CN. So this is called cyanohydrin. Okay, if you are using NaHSO3, okay, sodium bisulfite, okay, we will get a bisulfite adduct. So what is the use of this is, we can separate our aldehydes ketones from other compounds using this NaHCO3, because whenever in the given mixture aldehydes or ketones are present, it combines with that aldehydes ketones and forms some precipitate. Okay, only aldehydes ketones will form precipitate with NaHCO3. So that precipitate or the crystal can be separated out from the remaining mixture. Right now, so our aldehydes ketones are separated from the remaining mixture. Okay, is this clear? Yeah. Out of these aldehydes and ketones, ketones will be more reactive with this NaHCO3. Remember this point. Okay. Now, when a carbonyl group is reacting with Grignard reagent, what is this Grignard reagent formula? RMGX. It means one methyl, like one alkyl group should be there, like a methyl, ethyl, like that, and a magnesium metal should be there, and one halide like bromine, chlorine, like that it should be there. Okay, methyl magnesium bromide I can say. Now our alkyl group can attack as a nucleophile, like R group can be a nucleophile. So this can attack on this carbon. Okay, if it is attacking, what is happening there? So it will be forming CrO minus. Okay, since we need to do a workup or adding water at the last step, it becomes a OH here like this. So a ketone forms a tertiary alcohol. What I am saying, a ketone forms a tertiary alcohol. If it is an aldehyde, these statements are important, whatever I am writing. An aldehyde forms a secondary alcohol. Okay, a formaldehyde can form a primary alcohol. Sir, how you are saying all these steps? See, how many carbons are there? If I say this is a ketone, let us say acetone. Now already 2 carbons are there. A new carbon is entering there. So how many carbons are there now? 1, 2, 3. So 3 carbons around this tetrahedral carbon with 1 OH. So what you can say? It's a tertiary alcohol. See, let us say if it is an aldehyde. Here one hydrogen is there. Now what you can say, tell me? 1 carbon is there. We are newly adding 1 more carbon. So 2 carbons in the product side along with 1 hydrogen and 1 OH. So it becomes 2 carbon means secondary. Okay, if it is a formaldehyde, you will get a primary alcohol. Okay, so this is how you need to understand the concept. Okay, is this clear? Clear or not? Yeah, let's move forward. Okay, the next I told you, if in an alcohol it will forms acetal, ketol in dry HCl like conditions. Okay, if it is a amine or amine derivatives, we will get a shifts base, oximes, hydrogens we discussed in the previous slide. Okay, yeah, this already we did discussion. Okay, this is also done. Yeah, so this is done. Yeah, so now 2,4-DNP test, that is what 2,4 dinitrophenyl hydrogen we discussed now. So it will form yellow, orange or red crystal compounds. Okay, so it is used for identification of aldehydes and ketones. Okay, so now how can we reduce these to alcohols? Using reducing agents like lithium aluminum hydride. We already discussed this. Sodium borohydride, these things. Okay, and to the hydrocarbons, what I told you? 2 things. One is Clemmensen reduction and another one is Wolff-Kishner reduction, right? Yeah, so one more is called MPV reduction. Yes, we will discuss about this. Yeah, one more here I have oxidation reactions to be discussed first. Oxidation reaction we will discuss. So see, aldehydes are easily oxidized to respect to carboxylic acid using oxidizing agents like HNO3, KMNO4, K2Cr2O7, toluenes and Fehling's reagent. So what they are saying, aldehydes can get easily oxidizes to respect to carboxylic acids. See, this H is there now, this is aldehydic hydrogen, converts into a carboxylic acid when we are doing a oxidation reaction. Okay, this is easy and we can convert this using the oxidizing agents like this, Fehling's, toluenes, okay, K2Cr2O7, KMNO4 and HNO3. Okay, but oxidation of ketones is difficult. What I am saying, oxidation of ketones is difficult. We cannot make it using toluenes, we cannot make it using Fehling's, and we cannot make it using these things, but we can do it using HNO3 and KMNO4. Okay, so look at here, ketones are resistant to oxidation. So but undergo oxidation under vigorous conditions like strong oxidizing agents are required, like KMnO4 or HNO3 are required. Okay, because why it is so? Because if you write a carbon like this, okay, so in order to oxidize, in previous case there is only one hydrogen here, so this hydrogen get oxidizes to OH group, carboxylic acid is produced. But in this case there is no directly attached hydrogen, here directly attached carbons are there, so breaking of these carbon-carbon bonds are difficult. So that's why we require a strong conditions, okay, like strong oxidizing agents are required under vigorous conditions. Okay, so we can do now, we can oxidize this using like HNO3, concentrated HNO3, or this one KMnO4 under heating conditions, okay, strong conditions. Now what happens is, this compound will breaks into two pieces. What I am saying, breaks into two pieces. See here the reaction involves cleavage of CC bond adjacent to the carbonyl group. Wherever we have carbonyl group, adjacent to that cleaving of bonds takes place. Okay, and remember here in the oxidation of unsymmetrical ketone, see what do we mean by symmetrical and unsymmetrical? If both sides alkyl groups attached are same, we can say it's a symmetrical. But if you observe this side ethyl, this side methyl, so it becomes an unsymmetrical ketone. Okay, the oxidation of unsymmetrical ketones, the bond cleavage occurs such that the carbonyl group C double bond O goes with a smaller alkyl group. It means you have a question now, sir, which side I should break? See, you are saying that ketone will get oxidizes using concentrated HNO3 or KMnO4, but which side the bond cleavage takes place, either this side or this side? This is a big question now. So for that we have something called Popoff's rule. So Popoff's rule says that the carbonyl group should be always goes, it means major product, well for deciding major product, carbonyl group should be goes with the smaller alkyl sign chain. See which side we have smaller alkyl chain? This side. So carbonyl group goes with this and this will be another product. So now you will get CH3 COOH, okay, plus this one CH3 COOH, like this. So this group and this group get oxidizes to give respective compounds. Okay, so our carbonyl group is here only with a smaller alkyl chain. Okay, this is how you can write the final product. Okay, right. The next one here, yeah, the next one we need to discuss about, yes, we need to discuss about Tollens Fehling's reagent and iodoform reactions. We will do that in the upcoming session. Okay, in the next session we are going to do, yes. So till now we have completed oxidizing reactions and few more are there, and nucleophilic addition reactions are done. Yes. Okay, the remaining thing we will be discussing in the upcoming session. Okay, so thanks for watching. Those who are new to this channel, please click on the follow button, and you can share with your friends who are preparing for NEET, JEE and EAPCET exams. Thank you. You can share your feedback in the chat box. Thank you.